Hello and welcome to the second episode of Gist of It. Today we have a new talk for you from this year's GOTO conference out of Oslo. So it's just a few weeks old actually. And it has the title The Magic of Music Matching by Roy van Rijn, which is a guy out of the Netherlands, pretty close by where we're staying. He's at least working in Rotterdam, he said, right?
Yeah.
And he's a Java champion, actually. So, at least knowledgeable about Java, which he uses also for the language of choice, let's say, for the demos in this talk. But yeah, we'll see it in the future. So, a quick reiteration, because it's only the second episode. We'll go over the talk and summarize it for you in about half the runtime of the original talk. And at the end, give a small review of what we thought about it. And I would say, let's start.
Yeah.
Okay, so Roy begins the talk with explaining a few what he calls magic moments in software. So that these are things like when he first saw like a 3D game rendered and thought like it was, how the hell would you implement this? And generally the theme is like, if he sees a bit of software, which I think we can agree with, at least I can, that you start thinking about, or like some piece of technology rather, you start thinking about how roughly could this be implemented, right?
Yes, I think that happened to all of us.
Yes, and then he names a few more examples until he arrives at music matching.
Yes, then he starts explaining like a story of when he discovered this type of application such as Chatham.
Yes.
And how he decided that he wanted to understand how the application works.
Yeah, so just quickly for those of you who don't know at all what Shazam is, it's essentially an application, like mobile app, that you record some audio source with, like from some speakers in a cafe, for example. Like there's a song going on and you want to know what the hell is this song. And you click on some button in the app and it records about 10 seconds. And then magically, air quotes, detects a song for you and tells you, oh, this is a song, here you can listen on it on Spotify or whatever. And how does this work? And I do have to agree with him at this point. The first time I ever saw it, to be fair, at this time I wasn't really developing yet, because I mean, when did this came up 10 years ago or something, I guess.
Yeah.
But I had the same impression, I remember. First time seeing this was like, whoa, this is pretty next gen.
Yes, indeed.
Yeah. And another big use case, of course, which many of you, I guess, know as well, is the, like, although it has to do a lot of more things, is the YouTube copyright infringement matching. So if you have some song in a YouTube video that you upload, that the algorithm at YouTube detects it, and the ad money, for example, goes to the copyright owner of the song or something like that, or the whole video is deleted from YouTube.
Yes.
Okay, then start with the actual talk. What did he start out with?
Well, once he explained that he decided that he wanted to understand how this application works, he went like step by step explaining how to implement sort of a copy of this kind of application. And he first explained how to get or to read audio from your microphone using Java.
Yeah, and I think this was where we both agreed a bit. It was a bit useless and not super important for the talk, because then he shows like a slide with the implementation of the Java code of how to do that, and later turns out it's not super important. The reason why he did this, which you touched upon, is the narrative, let's say, of the talk is someone showed the app to him the first time on a Friday, and then over the course of the weekend, Saturday and Sunday, he implemented like a clone of Shazam essentially in Java, self-made. So of course he had to start out how to get audio, but that's about it. So the result of this was he has like a huge byte stream of sound that his input, in this case, microphone of his computer recorded. Yes, then he goes over explaining how well sound actually is recorded by a microphone. So
with the vibration.
Exactly. So you have pressure that the membrane in the microphone is picking up, and then essentially mapping this with the sample size and the frequencies to some audio input.
Yes.
But what you hear, of course, and this is where first important concept that he introduces comes from. And what you hear as a human is only a single frequency. So if you think about a sonic wave which like oscillates around like some middle point, higher frequencies having shorter wavelengths, lower ones having longer ones. I guess that everyone knows. Still, if you have like a sine wave, a simple sine wave of some sound, some single frequency, you don't actually hear as a human that it goes up and down as the sonic does, but you just hear like some steady tone, right?
Yes. Yes, he explains then how to turn this wave of the frequency into the frequency. How to...
Into a number, you mean?
Yes, exactly. Yeah, and he explains that this is done by using the Fourier transform.
Exactly. So yeah, that's all it is. He explains then how this essentially works. I think we can skip over this because it was interesting, albeit not very important to the talk.
Yes.
So, but indeed, the whole point is you have a wave of sound and you transform it to, at that point in time, essentially what frequency is there.
Yes, you obtain all the frequencies present in the audio sample that you have.
Yeah. So for example, you have like a 100 milliseconds of audio sample, like just some recording. What the Fourier transformation does is you get all the frequencies, so like just numbers in the end in hertz, that are present in these 100 milliseconds. Is that correct?
Yes. And here is the first problem, or
first barrier to overcome.
Exactly.
Yeah.
That if you do this transformate with an entire song, you get all the frequencies present in the song, but you don't know at which point in time these frequencies were present.
Exactly.
So what he does to solve this problem is to split the audio file or the recorded audio in smaller sample,
like slices.
Yes, like no, and yeah, it's a concept of windowing the
exactly. So if you think about like some audio like an editing program, which I guess most of you at least saw a screenshot of or something. Essentially, he on the time, so the x-axis just slides forward in a window of any size. It can be anything theoretically. Although the smaller you make it, the more accurate later the matching will be, right? But that comes at the very end. So, For example, he takes, let's stay with 100 milliseconds, regardless if it's accurate enough or not. He takes 100 millisecond window and then slides it forward over the song and calculates all the frequencies during the transformation in each sample of 100 ms.
Now, once you've done this Fourier transform with all your samples or windows of the audio source, you can basically know which frequencies are present in the song at which point of time, roughly.
More or less, exactly. Yeah. So, this is already where it comes in, right? The smaller this window is, the higher the quality. Yes. So if you take 100 milliseconds, you know all the frequencies in this 100 millisecond, which if it's a very complex song might be still a few hundred or thousand or whatever. Yes. But for example, if you dial it down to 1 millisecond, your window is so small that in an actual music song, it's likely that there's only one, or like maybe not one, but there's only a handful of frequencies at this single millisecond in time. Because you're not recording random noise, but like music, which follows some rhythm or pattern or whatever.
Yes. Then what he does is to plot these frequencies, basically by putting the high frequencies up in the graphic.
Yeah.
And the low frequencies
on the y-axis. So if you imagine like a coordinate system, x and y-axis, x is time again, and y is the the what is it called? How high the frequency is. So
Exactly.
the higher
The
notes,
frequency
yeah. Sorry, you're right. So the higher frequencies are higher y values, so higher on the y-axis, and lower frequencies are lower.
Yes.
And then what he also does is he records how loud the frequency is, which is just another dimension. So in his example, he shows it as a spectrogram, which essentially is what I just described: x and y-axis plus a color. So like a heat map, so to say.
Yes.
So the third dimension, which you don't see, like the Z or whatever you want to call it, is the color in this case. But what you should imagine is three-dimensional coordinate system: x time, y frequency, and z loudness.
Yes, exactly.
That's it.
And this is basically what he explained that he did in the first day.
Exactly. And then he goes on to the next day, where it gets a bit closer to actually the inner workings of these kind of apps like Shazam or the YouTube matching. So what he then does is fingerprinting. First of all, well, the idea is you take any song and, as the name says, calculate a fingerprint for it, so that later when someone shows you a recording, such as coming from the app, you can go through your fingerprint database and, like an actual fingerprint, see which matches the closest. Like, of course, this will not be 100% accurate. Otherwise, it has to be like a byte-by-byte copy match to get like 100% the exact same one. But fingerprinting is pretty good metaphor, because it will also not match 100% correctly, but more or less, and then okay, it's a match.
Yes.
But how does he do it?
He gets this spectrum analyzer that he created the first day and divides it by bands, which is basically like if you slice the spectrum horizontally.
The y-axis?
Exactly.
Into 8 bands.
And then he gets the higher frequency of each band.
Not the loudest.
No, the loudest is later.
Oh, sorry. Then continue.
And then does the same, but dividing the spectrum in the x-axis.
Yes.
Into slices, he calls it.
Yes.
And then he gets the loudest. And then it gives like certain points where the highest frequency is also loud, I guess.
Yes. So essentially what he then has in each of these bands, he has the frequency that defines this band the most, so to say, by being the loudest.
Yes.
So essentially what he has at the end is 8 samples of each slice. So if you imagine like the x-axis now, take one slice, let's say 100 ms again, and you look up or you record, you save if you slice the y-axis into 8 parts, what are the most defining frequencies of each part, and then you essentially have like a number, so to say. So what he does then is that he converts this into just a string of bits, a 0 being nothing, essentially.
Not an important frequency.
Exactly. And a 1 being the loudest in that band, which then leads to that he has like, in this case, he does it in 64 bits, but that's implementation detail really. So essentially what he gets is like a string of bits matching on the y-axis, a 0 being non-important and a 1 being a defining frequency of that band. So you get like a 64-bit number, so to say, which he then converts to a single long, so a single number. So that means that every slice, or every 100 milliseconds, he essentially receives a single number, a single number.
Yes. And then every song is represented by array of longs, which
of
is
all the slices.
The fingerprint of the song.
Exactly. So you would essentially then have every 100 millisecond is converted to a single number. So you have like 1,000, 2,000, 3,000, of course not in these steps, but any long, any number. The longer the song, obviously, the larger this list, but essentially it's just a list of numbers at the end.
Yes.
Okay, and I think that concludes this it was already on the second day, right? Yes. Sorry.
Now we only have left the matching part.
Exactly. So now what he did is he ran this algorithm, so to say, to retrieve these lists of longs over a library of MP3s that he had.
Yes.
So in his example, he did it with like around 500 MP3s. And then essentially has like these 500 fingerprints, which are 500 lists of numbers. Mm-hmm. And then the matching. How did he continue?
Yeah, basically he uses the audio reader from the microphone that he created the first day to obtain this song that's being played and recorded by the microphone of your phone. And then on the fly create this fingerprint of the song that's being recorded and compare it with the library of songs that he has.
Database, so to say.
Yeah.
Okay, and how he did this is essentially like a hash table. So he has a hash table from long to the offset in each song where it appears essentially. So if you think about this list, or it's an array really, or if you think about the array, he essentially saves where in this array does this long appear at which index. So that what he can do then quite quickly, and that's where the speed of this algorithm really comes from. He can quite easily look up like, give me the index of this long. If it doesn't find anything, if it's null essentially, then this just doesn't appear in there, this exact fingerprint slice, right? Mm-hmm. But if it appears, he gets the offset of the slice.
Yes.
Okay, so then he does this while reading in the byte stream of the currently recorded audio. He does this for every single sample that he records of the currently playing audio. He looks up through all the database, so essentially does loop all the time over all the songs he has. If there's any index in any of the songs or that matches.
Yes, and basically when he gets a lot of matches for the same song of these longs that he's calculating from the recording.
That are behind each other?
Yes, and then he has a match.
Yes, and then of course what he can also do, what he does then, he doesn't really show it, but yeah. Also, you can of course calculate some certainty that you have that it is a match, or how certain it is.
That you... In the talk, you can see that during the demo that he does, but he doesn't explain really how he calculates or estimates the certainty.
Yeah, but you can kind of estimate, right? It's probably how much the gaps are between each match and stuff like this. So, of course, what will happen if you don't have a byte by byte exactness of these bands, then the long will just not match any of your hashes in the song that you're playing back that you're trying to match, right? But by making the sample small enough, by making more slices, the likelihood that you come up with the same number in the end, representing the most important frequency at this current point in time, is just more likely to match anything because you made the sampling size smaller, and you have more points that can theoretically match. Yeah. So
it's basically the problem that you have in every single program, like precision versus efficiency.
Exactly. And then that's pretty much the explanation that he gives. And then next he does a demo, right?
Yes.
Pretty long one.
Yeah, exactly. He first does this demo where he plays some song on Spotify and matches it with this database of
predetermined, or like the database that he acquired earlier by running this fingerprinting over all of the same 500 songs.
Exactly. And in the demo, you can see that it really works.
Yeah, it's pretty impressive.
Yeah, it has a few misses, but I mean, it's pretty normal. It would be
it's
weird
like a clone
otherwise.
of a commercial product.
Yes.
So.
And he himself says that, well, it works, but there's a lot of room for improvement. But I mean, according to the story, it's done in only one weekend. So
yeah, but it is really impressive. I think this is one of the things that we have the link anyways in the show notes. For the sake of the demo, I would say it's worth watching that. Although the whole talk was nice. What do you think? Did you like it?
I like the talk. Well, it's what we already said, that some parts are not really important, but then for the sake of the storytelling that he does, which is very nice, the parts are interesting.
Exactly. So he definitely puts a bigger focus on exactly what you said, on narrative over content. So let's say the first 5 minutes are kind of not important at all, but for the whole story that he tries to tell with this, he did this over the weekend and blah blah blah. I see why he did it. Personally, though, my biggest gripe with it, although I also liked the talk overall, specifically seeing later the result was pretty impressive. So for me personally, some parts he really does in very much length, like what we said earlier already. He shows like how to obtain audio from a microphone in Java, which personally he could have just completely skipped. He could have said like, yeah, I googled that, would have still had the narrative for the story he tried to tell. But it just was not important. It didn't even use it later again in the talk, the information. While other parts like the hash lookup over his fingerprinting database was super short. Like the explanation was 10 seconds maybe. And this is like the core of the whole algorithm, really.
Yes. He does all the talk to get to the matching part. Yeah. And then the matching part, it's only one slide and very short.
Essentially, I think if you think about this as a narrative with like an arc of like the
storytelling.
Yeah, the storytelling arc. This is the tip of the arc, really, because there's the or maybe the demo is like, could be either of those. But if let's say the demo is the tip, then this is like shortly before the tip, the pinnacle, and the like, for me personally as a software developer, this is what I watched this talk for, to see like, okay, now I saw all this stuff and it's interesting and I understood everything. How is the actual matching done? And then it's kind of disappointing just because it's very short. If you would have left out the initial part and some other fluff in the middle, and made this like, instead of 10 seconds, like even half a minute, it would be more satisfactory to watch. Still though, talk is good from my point of view. And it's a small death to die.
Yeah, and it was a very nice talk in general. And in the end, he also does this where he evaluates how could this be used, which is also interesting, I think.
Yes. What was one point? Or a few?
He basically says that obviously this is used for song duplication,
like pre-recorded
detection.
Audio.
Yeah. Then he also does this other demo where he finds the point in the audio where the recording is being done.
Yeah.
So this could also be used to align subtitles, he says. And then obviously what you said at the beginning, copyright infringement in YouTube.
Yeah. So as a summary, I would say the demo is definitely worth watching if you just want a quick peek. We can link or timestamp just to the demo because it was impressive to watch.
Yes.
I would say overall good talk, but definitely quite lengthy for the amount of content.
Yeah, I agree.
What are your final thoughts? The same.
Yes, basically.
Okay. Then thank you very much for listening, and we see you in the third episode.
Yes. See you.